Welcome back. This is still section 3.2. This time, I'm sure some of you have already made the connection to the fact that whenever we talk about a value of x, we get a value of y, so we're going to get ordered pairs from equations like these where each value of x is a value in the domain and each value of y is a value in the range. This time, however, we're not going to take just fixed numbers of x to get values of y. We're going to actually go through and figure out, well, what does this function look like, right? If we've got a set of ordered pairs, as you know from our 3.1 section, we can plot those ordered pairs probably on the x and y coordinate system and get a picture of the function. So let's go through it right here. We're told we want to find, evaluate the function when x equals these values, -2, -1, 0, 1, 2, and 3, and then plot the resulting ordered pairs. And let's use these points to form a graph. Right? So what does this mean? Well, okay, we're going to get our values of x, and we're going to get our values for y in this function. So we're going to have to go through and calculate. When we say -2, what do we mean? F of -2 is what we're going to have to evaluate to get our value of y. But that means -2 times -2 plus 1. As we work that out, of course, that means 4 plus 1, which means we're going to get 5. And we're going to work our way down the list right here. So I'm going to give you all a few moments to pause the video, work this all out for yourselves, and then come back and check. So go ahead and pause right now. Okay, hopefully you've worked out at least these few points right here in your video, or sorry, in your calculations on your own paper. I worked it out on the video. But I've stopped right here for a moment just to indicate one thing. Take a look at what's happening. The y values go 5 to 3, then 3 to 1, then 1 to -1. What's the next that should be in this pattern? Well, if you worked it out, hopefully you would have found -3. Why? Well, we're going down by 2, right? Each and every y value is being 2 less than the one before it. So this should be -5. So hopefully you worked out your points and that's what you found. Well, let me try this out here on the paper. Let's see what we have. All right, so we've got our point -2, 5. Let's plot that. Let's look at -1, 3. Let's look at 0, 1, and 1, -1. And how about 2, -3? Picking up on the pattern yet? Well, certainly, this has to be the equation of a line in the plane. And if we were to go through and try and get a nice plot of this thing by drawing our line through each of the points right here, see if my aim's on. Boom. We got the graph, right? Now, how are we saying it's a graph? Why isn't it just the points? Remember, we're only using the values -2, -1, 0, 1, 2, and 3 to get our x's. However, we actually mean to include all the values between those whole numbers. So for instance, if I wanted to get an estimate of what's going to happen, let's say at -1.5, well, if I found f of -1.5, if that were one of the values that I could use here in my expression, right? Let's just try that. F of -1.5. What's going to happen? Well, if we were to calculate that out, we would find that we would get -2 times -1.5 plus 1, which is -2 times -1.5 is +3 plus 1, which is to say 4. Well, how does that correspond with what's on our graph? Take a look. We could probably point right here and get a coordinate point or so right here. It looks like if we were to work this one through. Here it is at about negative 1.5, we could go up and we could see that it goes with 4, right? So the point negative 1.5 goes with the coordinate 0.4. Try and make that negative 1.5 look a little bit more negative 1.5-ish, negative 1.5. I have to always take my time writing these out. But there, you see? That's the way this one would work out. Let's try one more. This time we're going to graph the function f of x is equal to 2 times the absolute value of x plus 2, and we're going to graph it at these particular points. Let's erase that here. Let's get a nice line. How about this one? There's my little sound effect. Okay, and we're going to use the values for x and get the values for y that go with it. And the values of x we said we wanted to use are at negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1. Okay, I'm kind of spreading that out. But let's pause right now. Let's have you work this out and get your table. And you can compare it to mine here. Okay, having worked these out, these are the values that I get. So let's take a little bit of time here and plot these things out. And let's see what's going to happen when we do. Of course, as we go down the list right here, we get negative 5, 6. Looks like we get negative 4, 4. We get negative 3, 2. We get negative 2, 0. And then it looks like it bounces up. We get negative 1, 2. We get 0, 4. And we get 2, 6. Right? Now, if we go through and give a plot of this, if we just follow the lines, looks like we've got a line that goes right down to this point, and then another line passing up through these points. And I said 1, 6, not 2, 6. Oops. All right, let's go back here and correct that. It's not 2, 6. Let's get this line out of the way here. Just move this for a second here. Plot that point. 1, 6. There we go. There we go. That's a beautiful thing. Okay, so there's our graph of our function. One more video coming up.